Has it ever been a thing where you would write an invisible marker and then have the thing where you scribble and see it? Is that like a that's is that a thing anymore? Because like when I was a kid, that was like a thing. What about slinkies? Are slinkies still things? I remember the commercials for slinkies, like when they first came out. You know, like it was like a black and white slinky, and like it's slinky, it's slinky. It's fun if you're a girl or a boy. Was it walks downstairs? That's oh my gosh, I'm old. All right, so um, how do we represent the stack? So for our um, so we have a stack of scopes, where a scope is a list of two lists representing name value pairs, right? So we have a list containing a bunch of two lists for name value pairs, and that lives inside of a um, I guess a scope. And then for our entire environment, we have this idea of a stack of scopes where we always check the pop, the front of that guy first. And if we don't find it there, we go move down to the next level. All right, so we're supposed to write add scope and resolve var. Was that what we're supposed to do for our homework? All right, so add scope takes in a scope, a variable name, and a variable value, and it returns an expanded scope with the new two lists added to it. So add scope of add scope. Here is our initial scope, the empty list, and so we get an A5, and then we get a B7 added to that same scope. So we're building onto a scope rather than extending an E and B, that type of thing. Okay. So we'll write this after our environment stuff up here, maybe. So we'll define add scope to be a lambda that takes in a scope, a var name, and a var val, those guys. Okay, and what we need to do is we need to get the two lists, the list of two lists from our scope, and we need to add this var val and var name to it. So if we kind of break this down into two steps, initially we get a scope that looks like that based on that inner one, right? So we're adding to the empty list the two list that is that guy. Then we're calling our add scope, passing that scope in with B and 7, and we're going to put in B and 7 onto this guy, and what are we doing? Is cons them together, constructing a new list, okay? And let's be, well, I was going to say we'd be fancy with it. So we're going to cons onto, depends if we want to put it on the front or the end. We'll put it on the end, doesn't matter. All right, so we're going to cons onto scope the list made of var name and var val. Is that add scope? All right, if we want to start expanding this a little bit, we can say define empty scope to be the empty list. That's how we've represented our scopes right now. So if we want to have a little constructor for empty scope. So then to test this guy, we might say add scope empty scope A and 5, something like that. And this guy should give us so, well, actually, that's not what that guy should do. So this is, so we really need to append, right? Since we're gluing it onto the end of the list. So there's our list containing that guy. Now, what we want our scope to actually look like, though, is a list containing this list. So if my scope comes in and it looks like the empty list, and I ultimately want to get, instead of it looking like this guy right here, I want it to look like the list containing the list A5. But my initial scope was the empty list, passing into A-5. So I need to take this list and take this list and put it inside. So I need to have a new list containing that guy. Now, what if, let's take it one step further, what if I had a B and a 5? So let's say I took in that scope and I had a B7, something like that. What I should get out of this is A5, B7. That's what it should ultimately look like. So if I have something that looks like this, how do I add to it another 2 list? What does cons do compared to append? Here we used append and we glued the empty list and the 2 list A5 together, giving us a single list. That's really not what we wanted. Before, when we had a cons here, let me put a, what's that, semicolon? When I had a cons here, I'm lost. I got the list containing the empty list and containing this guy. This right here is going to be a 2 list, isn't it? And I want to put that 2 list inside of another list. When I consed onto the empty list, so scope in this case would have been the empty list, correct? Empty scope was the empty list. So if I cons onto the empty list, a 2 list, I should have a list containing this 2 list. This list var name var list. This should be a 2 list there, and I'm consing that onto the empty list. Oh, hold on, this is kind of funky. So I'm consing that onto list A5. Cons list A5 onto, see, I think the issue is we have to deal with the empty list as a special case, maybe? No, there's the list A5. So I have to go backwards. So if you con something onto the empty list, notice that it's an empty list and starts with a fresh list. Because wouldn't we say that consing, right? Oh, hold on. No. This makes sense. Cons says cons this element onto this list. So that's what it did. It cons this element onto this list, giving us a new list that had that new element on the front with these other 2 things. What we really want to do is we want to cons our new element, which is the list A5. So this guy, we want to cons that guy onto our current scope. So adding to the front is really what we need to do in order for it to build the list correctly. So now this should give us the correct looking thing. So there's our list A5. If we then call add scope again on that scope and then B7, we get our list containing 2 lists. All right, so that's add scope. Then the other one we're supposed to write is resolve var. And resolve var takes in a scope stack. right? So we haven't really talked about how do we build scope stacks, but we have this idea that we have this list of scopes where a scope, so this returns the value of the most local definition of our var name in the scope stack, or false if it's not found. So for instance, if I give it, let's see, we have two scopes here, right? This is a scope and this is a scope. So that's a stack of scopes. I'm going to look at the most local one first and then keep going. So we're going to call it resolve var, and we're going to take in the scope stack, and we're going to take in the var name we're searching for. So it's going to be a lambda that takes in a scope stack and a var name. All right, and the first thing we're going to do is we're going to try to find that var name in the first scope. So maybe we say resolve var helper. This is a lambda that takes in a scope and a var name. And it's going to search through that scope for the particular var name, right? Now we know a scope is going to be a list containing two lists. That's what that guy looks like. So this is going to be back to our old pattern. So if null scope, then boil on the false, so lowercase f, whatever. That means we didn't find it. Otherwise, we want to ask the question, is the variable we're looking for, is it the variable name value pair that's represented in the car of that guy? So we want to say, is the car of our scope, which will be a to list. So we want the car of the car of that guy, which will give us the variable name, the name value pair. So the car of that guy, if that guy is equivalent to the var name we're looking for, if that's true, what do we do with it? We're going to say we want the CDAR, that's the, we want the, yeah, CADAR, the catter. I spell right? The car of the cooter of the car. That's right. So we get the first element, then we get the cooter of that guy, which is going to be a list containing the second element, then we get the car of that guy, which is the actual value associated with that. So we return the cadar of our scope. That's if we found it. If we didn't find it, then we're going to call resolve var helper on the cooter of our scope. And the var name. So resolve var helper should allow us to search for a variable name in a single scope. Make sense? So we take in a scope that's going to be a list of two lists. If I've run out of two lists to check, go ahead and return false. Otherwise, I'll look at the first variable name, the car of the car. So we'll take the car of the two lists, car of the scope, then take the car of that two list, which is the variable name. If it matches, then I'm going to go ahead and return the value associated with that to list. Otherwise, I'll call resolve var helper on the rest of the list, passing it the same var name. So then in resolve var, we ask the question. So we're looking at a scope stack. So probably we don't want to have to call it multiple times. So let's go ahead and do a let here. So we're going to say let try search equal resolve var helper, passing it the car of my scope stack. That's the scope we're looking for, right? And passing it the var name. All right, then we're going to be in the body of that let. So we'll ask the question if EQV try search false. So if I did not find the value when I searched for it in that current scope, then I'm going to call resolve var, passing it the cdr of my scope stack and the variable name we're looking for. Otherwise, I must have found it, so I'll go ahead and boil down to try search. I'm missing a slight parenthesis issue here. There we go. So this is the variable environment of the let. This is the body of the let, where we ask the question related to try search. If it gave me back a false, that means I did not find it this time around. So I'll go ahead and call resolve var again, passing it the next, I just burn the front of the scope stack off and I'll check it again. Otherwise, I must have found the resolved value, so I'll return try search. All right, so down here, let me go ahead and say define, we'll call it scope, to be that guy. And then let's give ourselves a second scope. Let's just mimic what we had in the, so we had A5, B7, then we have C3, it's the second scope. So we'll define scope 2 to be add scope. Empty scope C, what was it, C3, C2, C3, C3. So that'll be scope 2. And then we need to go ahead and create our define scope stack. And this guy is going to be the list containing those two things. So list containing scope and scope 2. That is a stack of scopes. Okay. And then we're going to go ahead and call resolve var. So in the example here, we said if we call resolve var on C, we should get a 3. Resolve var takes a scope stack. So here's my scope stack. And I'll pass it C, the variable I'm looking for. And I should get a 3 out of this guy. So there's my 3. If I say look for A, I should get a 5. Should find it in the first. And B, I should get a 7. All right, then in the second example, we had a bit of a different scope stack here. So this guy, yeah, I'll just build it. So we have A5, B7, and then we have a B3 in the second one instead of a C. So this is our B3. So now we can look for the most local definition of B, which should give me a 7, right? You'll find 7 first before it gets to the 3. So there's that 7. And if I'm looking for a, let's say, it should still give me a 5. And if I look for a C, it should give me a false. What row? Scope stack, var name. I must not be checking if it's the empty stack. I can't just randomly return the scope stack there if it only has, if it's the empty list. I actually could just do it here at the beginning. It'll just be our normal. So we'll say if null scope stack, then boil down to false. Otherwise, boil down to all that stuff. So this is what we do in the else of that if. So there's our false. All right, so we've advertised that our scope stacks. Well, first of all, any questions about those two things? Something along those lines for representing add scope and resolve var. So now we have to think about, in the wild, how are scope stacks formed. So last class we were looking at, do I still have Eclipse open? Yeah, so we were looking at, we have multiple functions. So at the top level here, in our program, we have a scope. So I'm going to actually just start building this scope up here. I'll put it a comment. So at the top level here, we have a scope, and in that scope, we have an A5. Okay, that's at the top level. Now, when we come to main here, so we're going to call this the program scope. When we come to main here, a new, let's call this scope stack. So this guy is a scope, correct? This guy is a scope stack. You might choose to label it, but for right now, we'll just leave it as flat lists. So this guy is a scope stack. You see kind of the benefit of labeling these guys? This becomes abstract at this point where now we're counting parentheses. Where if I said that this guy was a scope stack and this guy was a scope, isn't that cleaner? At least easier to read, right? Even though we're going to have to look at the car to kind of find out what kind of animal we're dealing with. As a human being, when we look at that, we can kind of tell, oh, what am I dealing with? All right, so if we want, we can leave it like this. We'll just update our other things. We're not too far in yet. All right, so we have a scope stack. So initially, when we have a program, we're going to create an empty scope stack. And in that empty scope stack, we'll have an initial empty scope. And that will, in this case, I have a single variable, a is 5, that gets added to that scope. Now, as soon as we defined this main method, when we're executing that program, we haven't introduced functions into our language yet, but assuming we had, as soon as we're executing that guy, a brand new scope gets added, correct? Actually, what I'm going to do here is I'm going to, before I do that, I want to copy this line. So that's our top level thing. So in main, what we end up working with here is a scope stack that initially is expanded to have an additional scope. Okay, when we run into this function, we have a brand new main, and we're going to say, oh, there's an empty scope associated with these guys. I think I mentioned something last time that in Java, we typically say whenever we see an opening curly brace, a new scope is formed. It's a little bit of a loose definition because the for loop scopes work more like threads, so it's a little bit of a weak, like a loose scope, but whatever. Leave it at the high level here. All right, so we go ahead and we generate a brand new scope. But now, does that scope go on the end in our scope stack? All variables resolve to their most local definition. So because we did our resolve variable, we're always looking at the front of that stack first. What we actually do is we create this brand new scope for main, and we push that scope onto our scope stack. Now, labeling this guy with scope stack makes it a little bit more difficult to push it on there, but that's not the end of the world. You just create a list out of the cons onto the cooter of your scope stack. Not that big a deal. Pull scope stack off, build a new list, put scope stack back on, and now you have your thing. All right, and then it's labeled better. So really we get something like this. Now, when we hit string s is equal to hello, we're adding a var. Where are we adding that var? To the most local scope, right? So what we kind of wrote two separate pieces, right? We wrote add var, and that add var we wrote adds a variable to a specific scope. We gave it the scope, said add a variable to this guy. When we add a var to a scope stack, we're going to add the var to the scope that lives at the front, the car of that scope stack. Make sense? So in this case, S would be equal to hello, like that. Let's just deal with one of those variables. So we're going to add it to our scope stack. All right, so we need to expand on this a little bit more. So let's go back into here. Let's update our scope since we're really early on at this point. And we're going to say our empty scope is written as scope. Actually, I think I could just do that, right? I could just do that. So our empty scope looks like that. And just while we're at it, why don't we say empty, let's do, we'll just say empty scope stack. That'll be the most flexible from when we add objects into our language. So we'll say empty scope stack. And this guy is going to be a scope stack let's just do it this way. We're going to say cons scope stack onto, not even cons. Create a list out of these two elements. Scope stack and empty scope. So an empty scope stack comes with one scope. So it's a list that has at the beginning of it the word scope stack and whose next element is an empty scope. That looks like this. And really our empty scope actually looks like that. So it's starts with the scope, the word scope, and contains a list of two lists that has nothing in it. So that's empty scope, and that's empty scope stack. Okay, so now let's reimagine add scope a little bit. So we'll still let add scope add a variable to a single scope. We'll just have to be careful what scope we pass it. All right, and this guy hands us the scope back, and then we'll have to re-put it onto our scope stack. So we're giving ourselves some utilities for working with our scope stack. So we'll say add scope, and this guy's going to take in a scope, a var name, and a var val, and we're actually not consing directly onto there because what's at the car of this guy is the word scope. So the scope we get is going to be the car of that guy. So what we're actually going to do is we're going to return the list containing the car of scope. Even though we know it's a scope, let's just deal with it generically, just in case we ever decide to change our label. Instead of being scope, we change it to a scope or something like that. So we're going to create a list out of car scope and the cons of list var name var val. So that'll be our new to list. And we're consing that onto the list of elements. So this is the CADR of our scope, which is the list of two lists. and we'll create a list out of that guy. Like that. Same logic, we just inserted this word scope in there, and we had to dig one step deeper to get to our list of 2 lists. All right, then resolve var. This guy took in a scope stack. And now we're asking ourselves, is this guy null? Can a scope stack ever be null? No, he's always going to have at least a scope stack at the beginning of it, the word scope stack. So we need to change this logic a little bit. And we need to say, let's actually just to keep this simpler, let's just erase this, and we'll start this guy from scratch so we can just piece it apart rather than interchange in there. So we have a scope stack. The slimmest we can be is having a scope stack with exactly 1 scope in it, right? So really what we want to do is we want to ensure that we do not call resolve var again when we're out of actual scopes. Okay, so we're going to go ahead and ask the question. If, do we want to do this with a conjugate? We'll do it with a. So if we're looking at the CDR, the cdr of a scope stack is going to be something that looks like, here's our scope stack. The cdr is going to be the list containing these scopes. Right? If I take the cdr of this guy, I'm going to be left with something that looks like this. The list containing those things. So here's a scope. Here's a scope. And then here is the, let's see, that's a scope there. That's what it looks like. And here's the list containing those 2 scopes. So it's when we're out of scopes in there that we know we're done. Right? All right, so we can check that up front, or we can check that before we pass in. So what we want to look at is we want to look at the car of the cdr. Well, the cdr is going to give me this guy. So really I can say, is the cdr null? Could ask that question. So we come back in here, I can say if null CDR scope stack, that is the list of stacks following our word scope stack. If that guy is empty, I've searched everywhere I can search, boil down the false. If that guy's not empty, that's where we're going to go ahead and search the first element in there. So we'll say our let, and what did I call it? Search, try search. Call it try search. So we'll say try search is going to be equal to resolve var helper. And you know what? Just for naming convention's sake, I want to change this to resolve var in scope. So now we've made this connection between a scope and a scope stack. And then make sure we rename it down there where we make our recursive call. All right, so this will be resolve var in scope of the first scope in the scope stack, which is going to be the CADR of scope stack. And the var name I'm trying to resolve is var name. So that is the first scope in the list of scopes associated with this scope stack. So then we can ask the question, if EQV, try search, false. I didn't find anything in there. Then I want to go ahead and call resolve var on my modified scope stack. I'm going to say resolve var on the cons of the car scope stack, which should be the word scope stack, unless we change it, onto, I want to go ahead and get the cooter of my scope stack, which is the list of scopes, and I want to get the cooter of that guy, the cooter of my scope stack, which is everything but the first element, the first scope in that guy. And that's the guy I'll cons onto my descriptor for scope stack, giving me a new scope stack with one fewer scopes in it. I'll pass that guy to resolve var with the var name if I didn't find it. Else, if I found it, return try search. All right, let's make sure these guys still work. Specs, given list. So the car of the car, where did I call car of the car of scope? My scope looks like this. I want the, oh, I didn't update this part yet for my resolve var in scope. We haven't changed that guy yet to take into consideration our new thing for our scope. So resolve var in scope is going to take in a scope and a var name, but now we just can't ask if the scope is null. Really what we're asking is if the cooter of scope is null. If I have nothing in the cooter of scope, I'm going to actually just rewrite this whole thing. It's easier than changing individual pieces. So I'll ask the first question, if I have no more variables in the current scope. That is, if I look at the list of two lists, which is stored in the cooter of scope, return false. Otherwise, I must have at least one variable in there. So I'll go ahead and ask the question, if EQV, now I need to get the first variable name. So the first variable name will be, if I have something that looks like this, I want the cooter, I want the car. So I want the car of the cooter, and I want the car of that. So the car of the cooter, the car of the car of the cooter. That's what I want, C-A-A-D-R. Car of the cooter of my scope. So I'm going to take the cooter, which gives me this guy. Then I'm going to take the car of that, which will give me this guy. Then I'm going to take the car of that, which will give me that guy. That's my B. I want to know if that guy is equal to the var name. If he's equal to the var name, then we found a value. How do I get my value? I take the cooter. So I'm going to return. So there's my cooter. That's going to be this guy. Then I want the car of that guy, which will give me this guy. Then I want the cooter of that guy, which will give me the list containing this guy. Then I want the car of that guy, the cadaver of my scope, if it does match. If it doesn't match, then I want to call resolve var in scope, passing it my updated scope, which is the cons of the car of my scope, which should be just the word scope, onto a slightly modified list of scopes, a list of two lists, rather. So that's going to be the cooter of the cooter. So if I get the cooter of this guy, I'm dealing with something that looks like this. And the cooter of him will be everything but the first element. Let's see, the cooter of this list will give me the list containing this, actually. So I want, we're actually not quite right yet. So the cooter of this will give me the list containing that. I need the car of that guy. So we actually need to go back and we need to fix this. This is actually a little bit scarier than it was before. So if I found my variable name, that is I take the cooter, which is this list. I take the car of that cooter, which is that. Then I take the car of that and the car of that, the CAAADR, because this guy's going to be wrapped. When I take the cooter of something like this, I'm going to get this piece inside a list. So I need to take the car of that to extract it. Okay? So that's the, where was I at here? CAAADR of our scope. That's equal to the variable name. Then I'm going to go ahead and return the value, which is going to be the cooter that gives me the list containing that, the car, which gives me this piece. Then I want the car of that, which gives me this piece. Then I want the cooter of that, which gives me the list containing this piece. And then I want the car of that. CADAADR of that guy. All right, and finally I'm going to cons the car of my scope, which is going to be the word scope, onto, I want to get this guy. So that is the CDR of my scope. And then to get that to list of two lists, I need the CADR of that. And then I want the cooter of that guy. That's the CDADR, the cadatter of that list. That's what I'll call resolve var in scope on, passing it my var name. Okay, so for homework, so test that. I'm pretty sure it works. All right, so for your homework, we want to have the ability to build a scope stack. Let's actually think about that for a second. Are we able to do that yet? Actually not. So be prepared for a quiz on Friday. No homework assignment. I'll put this stuff up on Slack, though. Make sure you review what we've done here today. Okay? All right. I will see everybody on Friday. The Bible homework is up, though.
The quiz, if we do have it, will be over scopes.
Over scopes, yep.